Welcome to the Gravity Engine tutorial on using physical units in your game design. Like a lot of n-body simulations, by default, Gravity Engine uses essentially arbitrary units for position and mass in the scene. And that's fine if you're building a game that has sort of orbits and arbitrary objects, but if you're trying to simulate physical objects, for example, orbits around the Earth or the orbits of planets around the Sun, it's very useful to be able to use the units from the real world. So what we'll do is we'll show you how that works in Gravity Engine by adding a Gravity Engine. And we'll look at it and open up the scaling menu here. And by default, we use these arbitrary dimensionless units. But if we're building an example where the International Space Station is going around the Earth, we'll pick a different set of units called orbital, and now we can work in kilometers, 10 to the 24 kilograms, and hours. And we can build a scene using data from Wikipedia pages that give us the diameter of the Earth and the mass of the Earth and the orbit of the International Space Station. There's an additional opportunity to adjust the kilometers to unit ratio as well as the game seconds per hour. So given that the International Space Station orbits every 90 minutes, let's say we want an hour to be about 10 game seconds so that an orbit will be 15 seconds. So we'll change that one. We'll leave unity units per kilometer as 1. That'll just make everything a little simpler as we enter the appropriate sizes of the Earth and the space station orbit. So now that we have a gravity engine and our units chosen, we'll take a planet and put it in our scene. So this planet has a model. The diameter of this model is 1 unit, and if we want it to be the Earth, then we need the diameter of the Earth, which is 12,742 kilometers. So we'll put that in. And that's a manageable unit in the context of Unity, although probably a bit bigger than a typical game would use. But that's a reasonable number that we're going to be able to work with. So we'll make sure that this planet is at the origin. So we'll put it at 0, and we'll put in the correct mass in units of 10 to the 24 kilograms, which in the case of the Earth is 5.972. So now we've set the mass of the Earth, and we've set the size of the Earth, and we can start to think about the space station. So to create a space station, we'll just create an empty game object. We'll want a model attached to that object that we can scale independently, so we'll create a capsule and just make it a child of the game object here. We'll call this game object ISS, and we'll take the ISS and put it on the planet, making it a child so that we can then add an n-body component and add an orbit ellipse. And so you can see here that in the orbit ellipse it's also aware of the units in which we're working. It has said that the semi-major axis here will be in kilometers. And the correct value for the orbit of the ISS, which is at about 405 kilometers above the Earth, which is 6,371 kilometers in radius, is 6776 kilometers. So we'll put it in that location, and the ISS has an orbit with an inclination of 51 degrees. So we'll take that in. And now if we zoom out here, we can see that we have this orbit skimming the surface of the Earth at the correct value. And one of the things we'll notice is that with a planet that's 12,000 units of scale, a capsule that's 1 kilometer big is not going to be visible in our scene. So we may want to exaggerate the size of the capsule for the purposes of visualization and up it to, say, 400. So now we can actually see, although it's not very big, our capsule here. And the other thing I'll do is we'll replace this main camera with a camera that I like to use in these gravity systems called the mission camera. The mission camera has a camera that's at the end of a boom, if you want to think about it. If we look at the camera here, we'd like to be maybe a little farther away, so we can see the entire Earth. And we'll get rid of this other camera in the scene. And the other advantage of this camera is it has this camera spin script attached, so you can use the arrow keys to change your point of view, and you can use greater than or less than to zoom. So now that we've added our tiny little ISS in orbit here, we can press play, and it should orbit around the Earth in about 15 seconds. Currently it's behind the Earth, and then as we wait, it comes along into the front of the Earth. And then if we want to make the orbit a little more visual, we can add another game object and add to that game object a trail renderer, maybe 10 seconds worth of trail. We need to start, say, with a width of 100, again, given our scales. Pick a material for our renderer. Change its name to trail, and make it a child of the ISS object. That trail needs to be at 0 offset with respect to the... There we can see our space station orbiting and leaving a trail behind. If we wish to add, for example, a second spaceship that's going to try and chase down the ISS, we can do that. And in that case, we don't want that spaceship to be on a particular orbit. We want to set its initial velocity and then let the player of the game change that velocity. So what we'll do in this case is we will create a new game object, call it spaceship, add a model for that object. We'll just use a cylinder, make it a child, spaceship, and we'll worry about the position of it in a minute. The cylinder will change the scale once again to make it visible in the game scene. Though it's not physically 300 kilometers, that's useful for the purposes of visualization. And then we'll add an n-body component to this spaceship. And now we'll set the initial position down in here, which will say at above the equator at an x position of 6776, so say the same radius as the International Space Station. And now we can specify its velocity in kilometers per hour. And if you go to Wikipedia and look up the velocity of the ISS, it's 27,600. So we'll put that in the Z direction, 27,600. So it will be in an equatorial orbit. And we can also take a trail renderer and put it on the spaceship, but we'll change the color to green. Now when we press play, we should have the ISS is back behind, so we'll just spin the Earth a little bit, see what we can see. So there's our spaceship, there's the ISS. We can see our spaceship is in the equatorial orbit, the ISS is in its 51-degree orbit, and you could then investigate the kind of motions you would need to rendezvous with the International Space Station. This concludes the demonstration on how to use units to create realistic physical scenes in the context of the Earth's orbit. Thanks.